Good afternoon. Welcome to ARC339, Best Practices for IoT Architecture using AWS's Smart Product Solution. I'm Steve Blackwell. I'm the Worldwide Technical Lead for Manufacturing in AWS. And presenting with me today, I have Bamsak Lee, one of our solution builders from our solution builders team responsible for the Smart Product Solution. So what we're going to cover in today's session, first of all, I'm going to start off and kind of talk about, from a manufacturing industry, what we see as connected or smart product and the reasons why, and kind of lead into why we created the smart product solution. And then talk about a couple of use cases. I'm then going to hand over to Bamsak, who's going to talk about our smart product solution, give you a quick intro into that, and then start walking through the individual architectural components that build up our smart product solution and describe why we actually chose to do how it is. We're going to then cover a little bit about how you could take our smart product solution and customize it for your use case. And then finally, we'll wrap up with a quick demo of the UI of the solution itself. And if we've got any time left over, we can have a little bit of QA. Okay. So why and what is a smart product? So as I said, I look after the manufacturing industry. And within manufacturing, we see a couple of industry trends coming along. The first one is obviously data. We're now in this digital transformation world where data is really becoming kind of the new oil driving it. And if we look at it from a kind of connected smart product point of view, this comes in two different variants. In manufacturing across the whole value chain, we have, like within the factory itself, we actually have the machines that are actually, creating your product or manufacturing your recipes. And actually for us, they are connected smart products that actually generate that data that sends, information out. And that kind of feeds into kind of our digital executed manufacturing. As we're getting into this world of, our design engineers, our process engineers using computer-aided design, computer-aided engineering applications, they can then feed into our computer-aided manufacturing applications that can feed potentially our smart products on the actual shop floor. And then we then look at actually, okay, so we want to build and we want to build against a plan. How can we ensure that we're actually, meeting our actual demands? And this comes around, quality, predictive maintenance. So we see kind of, smart products as really, as an industrial device, be it a CNC machine, be it a furnace, kind of fitting into that, enabling us to ensure that we can meet the demands of the manufacturing plant. We then look at the other side of the manufacturing value chain, which is, once you've created that product, taking that product and actually being connected. And apart from it, from an industrial point of view, we also then see kind of parts of the industry, the white goods, creating the connected fridges, connected microwaves, and also then into like the automotive industry, the consumer goods with home thermostats, and also aerospace with the connected engines and so forth. So manufacturers are really looking to kind of extend their engagement with their customers through connected products. And then once that product is actually connected, it enables them to then actually provide additional functions, features, engagements with their customers. And vice versa, it also allows them to then actually bring in data of how that product is actually being used out in the field. A huge amount of wealth of analytics being taken of how your product is actually operating within its conditions. And then finally, we then look at, okay, so now that product is actually connected, the manufacturer can then actually start looking at changing their business model. Rather than actually selling a product, they may actually change to providing it as a service. And we're seeing this very much in the aerospace industry. The GEs, the Rolls-Royces of the world don't want to sell aircraft engines. They want to provide flight time. So it changes their whole dynamics, and that's really driven by that connected product. And then finally, the last part, if you're actually a manufacturer, one of the big drivers is energy consumption or sustainability actually on your shop floor. So, being able to manage and monitor, your machines you're using, that smart product really kind of feeds into that. So, from a smart connected product, we see it really affecting, and being part of the whole industry trend. So in response to kind of those industry trends, we created the AWS Manufacturing Reference Architecture. Okay, I actually do have a session, Chalk Talk tomorrow, MFG 303, where actually we'll deep dive into this. But, you know, and there's a URL at the bottom of an interactive online version that you can actually go to and use. But the reason why I bring this up is, you know, within the reference architecture, we see the connected smart product being fundamental to the key part of what we see the reference architecture being, which is the data lake. Okay, bringing information all together from different parts of the business so you can start to do correlation, analyze, and start to bring insights to the business. And your smart product, as I said, could be an industrial device, a connected machine within your factory, being on the left-hand side, or it can actually be that connected product, that thermostat, that fridge, that car out in the field that's actually bringing in that additional information of how that product is being worked out there. And that really then kind of feeds into, you know, what we see as the manufacturing flywheel, which is we have, you know, three parts of the business, the beginning of the value chain, which is where the design engineers and the process engineers come in and are actually designing, looking at requirements, addressing customers, okay, and there's a closed loop there. But then there's information from that then feeds into the actual factory itself. And then when you're looking at, you know, OEE, quality, you know, throughput, you know, you're using the data there. And then also you can then take that data and then help feed, you know, how that product is being manufactured, how it's actually being used. And you've got your smart product out in the actual field itself being used and information flowing through. But the last part is then creating that closed loop, you know, bringing that data from the field back into our design and process engineers to be able to help them understand how the product's been working, how they can actually design better products and iterate new products so we can get a faster cycle time of bringing the product quicker to market. Okay. So finally, before I hand over and we actually get into like the details of our smart product solution, I want to talk about, you know, kind of smart product use cases, and I want to do that through some of our customers. So the first one I'll talk about is Valmet. Valmet manufacture paper mills. Okay, these are large machines that have the length of a factory. And what they did is they wanted to create a connected paper mill so that they could actually pull off data to actually optimize the manufacture of that paper to ensure that they're providing quality of the paper it's manufacturing and ensure that it doesn't break down. And that's really to provide it to their customers. Okay, so they're collecting data off the machines, and they're actually then using that data to train machine learning models that they can then deploy down onto the actual connected paper mills so that they could actually analyze and improve quality and reduce downtime. The second one is iRobot. So they created a connected vacuum cleaner as part of their greater smart home ecosystem. And the final one is SKF. They've created a system called Connected 24, which is for connected ball bearings. You find it strange, but actually, you know, they create ball bearings that actually go into wind farm turbines or into mining machines in huge mines, where, you know, to send a person out to provide maintenance to those and actually keep them lubricated takes a huge amount of time and effort, especially if you look at, you know, wind turbines in the middle of oceans and seas. So they created this system, Connected 24, which actually monitors the ball bearings, applies lubrication when it starts to detect friction, but more, they've actually then built upon that, bringing that data in and building a system that their customers can actually monitor and understand how they're operating. You know, and key to that, you know, is the underlying technologies around those use cases. So, you know, being able to provide those functions and features is all around about having secure connectivity to those actual connected products out there. Okay, being able to ingest the telemetry from the sensors actually on those connected products. And then finally, being able to manage that fleet of products you've got out there and actually then be able to provide remote controls over the updates on that. Okay? And these are the fundamental building blocks that we looked at when we designed our smart product solution to show you, you know, how you can actually do this using the AWS cloud. So at this point, I'll hand over to Mantak, who's going to then talk you through our smart product solution.
Song Lee. I'm a solution builder of the smart product solution. So let's see what is smart product solution. So a lot of customers ask that AWS has a lot of services, but they don't know how to integrate to build their own smart product solution. That is why we built this solution to the customers so that the customer can refer to smart product solution architecture easily and customize it fit into their production environment. So smart product is a reference architecture which shows the best practices of IoT architecture, and it provides the art of the possible so that you can build your own smart product solution with this solution. So by default, we developed this solution with HVAC devices, but if you have other devices, then you can customize the solution fit into your devices as well. So you can use whatever devices you want. For the more information after the session, you can visit the Smart Product Solution webpage to see how you can deploy and customize the solution as well. So let's dive into the design decisions of the Smart Product Solution. This is the overall architecture of Smart Product Solution. So you might have your own devices, and your devices are going to connect to AWS IoT Core using X.509 certificate. And AWS IoT Core can deal with billions of devices and trillions of messages, so it's very scalable. And Smart Product Solution, it has command status service and just-in-time registration service and AWS IoT Device Defender for security and telemetry analytics pipeline for your telemetry data. And it has event message proxy service, which handles events message from your devices. And all the event data or command data is going to put into DynamoDB table. And it also has notification service to notify you for the certain events. And the solution itself provides on a web console so that you can see the demo of the UI on this solution. And it also has API service. So if you have your own owner web console, then you can just use API service, integrate with your services. And all of the things are serverless. The reason why we chose serverless architecture is that we would like to give you we would like to free you from managing your own resources, such as EC2 instances. So you can only focus on your development area. Okay, so let's start from the registration process. For device registration, there are two options you can choose. One is just-in-time registration, and the other one is just-in-time provisioning. For just-in-time registration, you need IoT rule, and you need just-in-time registration Lambda function. And the other one is just-in-time provisioning. And for this one, what you need is provisioning template and role, which is attaching to your CA certificate. Both of them are going to be triggered when your devices with new certificates are trying to connect to AWS IoT Core. Then AWS IoT Core is going to manage the rest of the process. So these are the components for the just-in-time registration itself. So we have AWS IoT Core and just-in-time registration Lambda function and Amazon DynamoDB table, and we also have owner web console to register your device through the web console. To look into the just-in-time registration workflow deeply, So when your devices with new certificate is trying to connect to AWS IoT Core, AWS IoT Core is going to send the registration message to certain topic, which is the reserved topic. So you can see the topic there. So the topic looks like AWS/events/certificate/registered. And the topic is going to have your certificate information. Once AWS Core got the information, then just-in-time registration Lambda function is going to be triggered by IoT rule engine. So when just-in-time registration Lambda function gets the message from AWS IoT rule engine, then the just-in-time registration Lambda function can create policy for your devices and attach policy to the device certificate and attach certificate to your devices, which is thing in AWS IoT Core. For the smart product solution, we are using common name on IoT certificate for the thing name. So thing name should be unique in IoT Core. So if you are using this solution or if you are using your own solution, you need to make sure that thing name should be unique. After that, just-in-time registration can register your devices into DynamoDB table as well. So what is the policy for your devices? You may want your devices to connect to AWS IoT Core services, and you would like to control your devices remotely. There are two options you can control your devices remotely. So one is using MQTT, and the other one is using Shadow. So for using MQTT policy, you need publish, subscribe, and receive. And for Shadow, if you are using Shadow, then you need get thing shadow and update thing shadow. And to connect to AWS IoT Core service, you also need a connect policy so that your devices can connect to AWS IoT Core, and you can control your devices remotely with this policy. But there are more policies, so this is some examples that we chose for smart product solution. After registering, you may want to search your devices. Even though we have DynamoDB table, you may need better way to search your devices. In that case, you can use AWS IoT Device Management Fleet Indexing to manage a lot of devices in your AWS IoT Core. So to enable fleet indexing configuration, you can simply query the result with thing name, description, and attributes. If you enable just thing indexing, then you can use thing type, or just you can use attributes, but you only have 3 searchable attributes. So with fleet indexing, you only have 3 searchable index. But if you use thing group indexing, you can have 50 searchable attributes, so you have more choices. So depending on your use cases, you can choose what attributes you are going to use on your thing. Next is the event message proxy. So once you are done with your registration, you would like to get device events from your devices. So for handling your events from your devices, we are using AWS IoT Core and event message proxy and notification service. And also through the Owner Web Console, you can trace your event. So this is event message proxy workflow. So once your devices are sending any event message to AWS IoT Core, then AWS IoT Core is going to get that message to the topic. And then IoT rule engine is going to send that message to event message proxy Lambda function. What event message Lambda function can do is to insert your event message into DynamoDB table so that you can see your events through the web console. After that, event message proxy Lambda function is going to send that message to notification service so that you can get notification. For the smart product solution, we are using setting table which contains which events you would like to get the notification. So for example, we have error message or warning message, info message, or diagnostic message. So you can set up the level of the events you can get notification. But to customize this one, you can also set up your threshold to get any notification from notification service Lambda function. But what if you have a lot of events to send from your devices? Your Lambda function has a possibility to be throttled if you have a lot of devices and your devices are sending a lot of messages to AWS IoT Core. In that case, you can put Amazon Simple Queue Service or Amazon Kinesis in between IoT rule engine and event proxy Lambda function so that you can give some buffers to Lambda function to so that your Lambda function cannot be throttled easily. This is another option you can choose for your events data. We have AWS IoT Event, which is managed service. So if you are using this service, then you don't have to worry about anything. Just you can use this one. So with AWS IoT Event, whatever data you want, you can easily ingest into the AWS IoT Event. Then rules can send messages to other services. And you also can trigger a range of actions, which means that you can mix multiple data to make alerts. And AWS IoT Event is very scalable, so if you have a lot of devices and your devices are connecting to AWS IoT Event, then you can, AWS IoT Event will be scaled, so you don't have to worry about the scalability of the service. And finally, you can easily integrate to and from other services with AWS IoT Event. And you can use if-then-else statement to decide which action you would like to have. For example, if you want to send notifications to users, then you can do that. Or if you want to do some custom actions, you can do with this one. Your devices is going to send telemetry data as well. For telemetry analytics pipeline, smart product solution is choosing AWS IoT Analytics services. So we have just AWS IoT Analytics service and Amazon QuickSight to visualize the data. There are various options you can choose, and here are a few options. So one is AWS IoT Analytics, which we chose because it is designed specifically for IoT, and it has storage of time series data as well. So you can query time series data with AWS IoT Analytics. And it also has device-specific data enrichment, which means you can enrich your data. And you can query on large data set as well. And you can have predict flip management with AWS IoT Analytics with AWS IoT Greengrass and Amazon SageMaker. If you want to have real-time processing data, then you can choose Amazon Kinesis Data Analytics instead of AWS IoT Analytics so that you can just process real-time data easily. But if you have your own analytics or analytics solution, then you can choose Amazon's simple storage service as a destination of your data, so that you can just put your solution to look at the S3 bucket, and you can analyze your data. Or you can integrate with other AWS services like Amazon Athena with Amazon Simple Storage Service as well to analyze your telemetry data. So this is the workflow of telemetry analytics. So your devices are sending messages to AWS IoT Core as well. Once AWS IoT Core gets the topic, the IoT rule engine is going to send that message, data to AWS IoT Analytics channel. Once channel gets the data, it will send the data to pipeline. What pipeline is going to do is that on the pipeline, you can convert or enrich your data with, so there are two options. One is to use just simple formula. For example, if you want just the plus minus data, then you can do, or you can use Lambda function to enrich or convert your data as well. Once it's done, pipeline is going to send the data to data store, so the data store can store enriched or converted data into it. After that, you can simply query to choose which data you want to show on dataset. So this is the example of how you can use pipeline Lambda function. So on the left side is the input data of the smart product solution. So there are many data, but I put just these ones. And right side is the converted data. So your devices is going to send Fahrenheit temperatures to AWS IoT Core, and it is going to send timestamp as well. But not everyone are familiar to Fahrenheit Celsius, Fahrenheit temperature, so you can convert Fahrenheit temperature to Celsius temperature as well. So you can see the right side, you can see the temperature has been converted to Celsius temperature. In addition, if you have a lot of devices around the world, maybe your devices are going to send data with different time zone. In that case, you might be confused, so you can convert your timestamp to unify the time zone to whatever you want. For example, we used UTC. After that, when it's done, you can integrate with Amazon QuickSight easily, so that you can create whatever chart you want. For example, if you can create pie chart or line chart like this, or any kind of chart you want, you can create to visualize your data. So let's talk about the remote command. So users of device are going to execute any remote command through the owner web console. Once user creates any commands, then commands going to the API service, and command API service is going to send the device command to AWS IoT Core. And then we have command status service to check the command status as well. To deep dive into this one, so this is the workflow that we chose. So device users can execute commands on UI, so then command service Lambda function can do two things. One is sending IoT desired state to a IoT shadow, and the other one is publish command topic to AWS IoT Core. On device side, what you can do is just sending IoT reported state to IoT shadow, or you can publish command topic to AWS IoT Core as well. And the devices can subscribe topics as well. So every devices can catch every comment from web console. Once any commands are sending to AWS IoT Core, IoT rule engine is going to send the message to command status Lambda function, which updates the status of command. So for example, if your command failed, then the Lambda function is going to update the DynamoDB table with status with failed and the reason of the failure. On the device side, you can choose two different ways to handle remote commands. So the first one is using shadow state, and the other one is using IoT topic. So on device, you might have AWS IoT Greengrass, or you can use AWS IoT Device SDK. And with AWS IoT Device SDK, you can get the delta of the shadow, and you can get the IoT topic message as well. So first one is about the shadow state. So when you create any remote command from your web console, then it is going to have desired state, which says like target temperature is 68, and your device is going to report like target temperature is now 70 on the device side. And AWS IoT Device SDK is going to catch the delta of the desired and reported state. So it will have delta, which says target temperature is 68 from desired state. If device gets the delta of the state, then you can execute to change your target temperature of device. And another way is to use AWS topics. So your device is going to subscribe the topic as well. So once your user creates any commands through the web console, then device is going to get the topic. So topic would be look like target temperature is setting to 70 degrees. Then you can change your device target temperature as well. So you might need security as well. For security, we chose to use AWS IoT Device Defender. With AWS IoT Device Defender, you can have audit or detecting violation. What audit is doing is you can set up the scheduled audit report, and then AWS IoT Device Defender is going to send notification to you based on your schedule, so that you can have audit report on your side. With detecting violation, you can set up how your device should behave, and you notice that if device behaves some abnormal actions, then you can send notifications as well. For example, if your devices get a lot of TCP errors or a lot of packets, then you can send notification to you through Amazon Simple Notification Service. For the smart product solution, we are only using audit because you might have different violation detecting technology or threshold. So we only choose to enable audit for you. So currently, there are 10 checks available on audit side. So each has the severity and each has different actions. So you can choose what checks you would like to get audit report from AWS IoT Device Defender. And this is the summary of the best practices that I explained previously. First one is serverless architecture, so then you can free from managing your actual resources. And second one is device registration. So there are two options, but I've shown that just I've shown just-in-time registration process. And third one is search devices with fleet indexing, so then you can search your devices, whatever, how many devices you have, it doesn't matter. And for the message handling, you can use rule engine. So for smart product solution, we have four rules, which is registration, event, telemetry, and command. And for data analysis, you can choose AWS IoT Analytics for your telemetry pipeline. And lastly, for security, you can enable AWS IoT Device Defender. So let's talk about the customization. By the way, this solution is available with open source. You can customize, so you can get the source code through the GitHub repository as well. But if you launch the smart product solution itself has CI/CD pipeline as well. So CI/CD pipeline includes AWS code commit, AWS code pipeline, AWS code build, AWS cloud development kit, and AWS cloud formation. So once you change any source code on the AWS code commit repository, then AWS code pipeline is going to be triggered by CloudWatch event, and then the source code is going to be built again, and it is going to be deployed. With AWS Cloud Development Kit, you can also code your infrastructure level as well, so that you don't have to worry about AWS Cloud Formation template. Okay, so let's see the demo UI. So once you launch the solution, you will see 3 stacks. So the below one, so bottom one is the actual stack you are going to launch. And the middle one is about the CDK toolkit, which contains cloud formation template generated by CDK. And the above one is the actual stack, which contains every resources of smart product solution. Okay, so going to the smart product solution stack, and you can go to output, then you can see the URL of the smart product solution. Once you click that, you can log in, but before logging to the smart product solution, you need to create an account. And once you log in to the console, then you can see the registered devices. Let's start from the device registration. So click that. I need serial number and model number, which is in reference table in smart product solution. So going to the DynamoDB table, I can see the device ID. So device ID is going to be serial number, and put that into the serial number, and I give device name and give model number and register it. And it provides how you can create your certificate and trigger just-in-time registration. I will just finish. Then device status is pending because just-in-time registration is not being triggered. So this is the EC2 instance, which will act like a device. So I will execute script to create certificate and trigger just-in-time registration. Once it's done, it also has device simulator, which will send telemetry data every 10 seconds to the solution. So going back to the console, when I refresh the page, then it says that the status has been completed. If I go to the main page, then it says that connected status is connected. Get back to the detail page of the device, then I can see the device status. And going to the commands, it has mode and temperature. Once I change the mode to heat, then device is going to say that the heat is on. And if I change the target temperature through the web console, then the device is going to say that my target temperature has been changed. Okay, so go back to the console, then I can see the command details, so I can see which command has been created by the user. And going to the event log, then I can see the event log of this device. But if I go to event history, then I can see every device's every event. So it contains so you can see a lot of devices and a lot of levels of events as well. But if I go to event alerts, then event alerts only shows the certain level of event which I set up. So right now, I just set a warning and error message to show here. So to change the alert level, then I can go to user setting. Then I will change it to info. Then going back to event alerts, then it only shows the info level event. When I refresh the page, then the notification says I only have 10 new alerts because I changed my alert level. Once I read the event, then it will be gone from the event alert because event alert only shows the unread event. So I read 3 events. So after that, once I refresh the page again, then it says that I only have 7 new alerts. So going to the main page, I can delete the device, but before deleting the device, I can terminate the device simulator. So terminate the device simulator, and I can delete the device. Once it's done, a device is going to be gone from AWS IoT Core. For the analytics, you can use Amazon QuickSight. So click the new analysis and click the new data set. Then you can see AWS IoT Analytics. To click this one, you can see Smart Product data set. So you can create, but I've created one, so I just click Cancel. Once it's done, you can create this kind of graph. So for example, I've created Celsius temperature with devices per time. Okay, so let's wrap up. I hope you might learn the best practices for IoT architecture using smart product solution. So for the smart product solution, if you want more information, you can visit the website as well. And after the session, you are here to learn a lot of things. So you can go to AWS training and certificate and to meet other experts as well to learn more about things. So before ending the session, do you have any questions? Okay, so maybe after the session, you can come to us to ask any questions regarding smart product or smart product solution itself. Before leaving the room, you can complete the session survey in the mobile app. And thank you.
Thank you very much.